Hi everyone, hope so you all are fine. So now we will see ipv4 header, that Internet Protocol version 4. So it is the fourth version in the development of the Internet Protocol and the first version of the protocol to be widely developed. Together with ipv6, it is at the core standard-based inter-networking method of the Internet. ipv4 is a connectionless protocol for use on packet switch link layer networks. That is, for example, Ethernet. It operates on a best effort delivery model in that it does not guarantee delivery. These aspects, including data integrity, are addressed by an upper layer transport protocol, such as the TCP protocol. So the ipv4 header packet consists of 14 fields, of which 13 are required. The 14th field is optional named options. The ipv4 packet header consists of 20 bytes of data. The first thing come here is the version. The first header field in an IP packet is the 4-bit version field. The version field indicates the format of the Internet header. Version identifies the IP version to which the packet belongs. This 4-bit field is set to binary 0100 to indicate version 4, that is ipv4, or binary 0110 to indicate version 6, ipv6. And then let's come to the second point, that is header length is about 4 bits and it's the internal header length, telling the number of 32-bit words in the header. Since an ipv4 header may contain a variable number of options, this field specifies the size of the header. This also coincides with the offset to the data. The minimum value for this field is 5. Being a 4-bit value, the maximum length is 15 words. So if we calculate 15 with multiplying with 32 bits, the output is 60 bytes. So the third field is the type of service, now known as a differentiated service code point, that DSCP or the TOS. The TOS field is used to carry information to provide quality of service features. New technologies are emerging that require real-time data streaming and therefore make use of DSCP field. An example is voice over IP, that VoIP, that is used to interactive data voice exchange. Type of service allows the selection of the delivery service in terms of precedence, throughput, delay, reliability, and monetary cost. So let's come to the second point, which is the total length. This 16-bit field defines the entire datagram size, including header and data in bytes. The minimum length of datagram is 20 bytes. So let's calculate few things like 20 byte of header plus 0 byte data, and the maximum size is 65,535 bytes. The maximum value of a 16-bit word. The minimum size datagram that any host is required to be able to handle is 576 bytes. Sometimes subnetworks impose further restrictions on the size, in which case datagrams must be fragmented. Fragmentation is handled in either the host or packet switch in ipv4. Just remember this, the total length basically means the total length of the header including the data, and the maximum size is 65,535 bytes. So the second point is about the identification. This field is an identification field and is primarily used for uniquely identifying fragments of an original IP datagram. Some experimental work has suggested using the ID field for other purposes, such as for adding packet tracking information to datagrams in order to help trace back datagrams with spoofed source addresses. So there is a flag. There are 3 types of flag. Like the one, if the flag is 0, this means it is reserved, and it is 1, then it means don't fragment, and if the bit is 2, then it means more fragment. So a 3-bit field follows and is used to control or identifying fragments. Let's come to the second point is the fragment offset. The fragment offset field measured in unit of 8 bytes blocks in 13 bits long and specifies the offset of the particular fragment relative the beginning of the original unfragmented IP datagram. The first fragment has an offset of 0. This allows a maximum offset of 2 raised to power 13 minus 1 into 8, which is approximately equal to 65,528 bytes, which would be exceed the maximum IP packet length, which is 65,535 bytes. So then we will come to the second point is the time to live, that is TTL. It is of 8-bit field. This field indicates the maximum time the datagram is allowed to remain in the internet system. It is a field containing the value 0. Then the datagram must be destroyed. This field is modified in internet header processing. The time is measured in unit of seconds, but since every module that processes a datagram must decrease the TTL by at least 1, even if it's possible the datagram is less than a second. The TTL must be thought of only as an upper bound on the time of datagram may exist. The intention is to cause undeliverable datagrams to be discarded, and the bound of maximum datagram's lifetime must be numbered to range from 0 to 255. And then we will see about the protocol, that this field contains the protocol used in the data portion of the IP datagram. The Internet Assigned Number Authority, that is IANA, maintain a list of IP protocol numbers. Then we will move toward the header checksum. This is basically 16-bit checksum field and is used for error checking of the header at each hop. The checksum of the header must be compared to the value of this field. If a header checksum is found to be mismatched, then the packet is discarded. Errors in the data field must be handled in an encapsulated protocol both by UDP and both have the checksum field. So there is another thing about the source address and the destination address. So in source address sets the source IP address. The option lets you specify a custom IP address to be used as a source IP address in sent packet. This allows spoofing the sender of the packet. Can be an ipv4 address or a host name. So destination address is an ipv4 address indicating the receiver of the packet as with the source address. This may be changed in transit by a network address translation. So in last we will see about the option. Basically option is the additional header field may follow the destination address field, but these are not often used. The value in the IHL field, internet header field, basically must include enough extra 32-bit words to hold up all options. So the list of options may be terminated with an end of option. This is only necessary if the end of the options would not otherwise coincide with the end of the header. So the options are variable length. There may be 0 or more options. There are two cases in the format of options: a single octet of option type, case 1, and the case 2 is an option type octet, an option length octet, and the actual option data octet. The option length octet counts the option type octet and the option length octet as well as the option data octet. The option type octet is used as having 3 fields: bit copied flag, 2-bit option class, 5-bit option number. The copied flag indicates that this option is carried in all fragment on fragmentation. 0 means not copied and 1 means copied. In typical IP implementation standard, protocols such as TCP and the UDP are implemented in the OS kernel for performance reasons. Other protocols such as ICMP may be partially implemented by the kernel or implemented purely in user software. So this is all about ipv4. I hope you understand this, and if you have any question you can ask me. I will answer it, inshallah. Let's meet you in the next lecture with a new header. And if okay, thank you. Allah Hafiz.